Hello and welcome to our first podcast on Unit 1. Today we're going to be discussing Section 4.1, which are early theories of matter. I'm Mr. Sakaguchi,
And I'm Mr. Lin.
and away we go. The first people of record who kind of began the field of chemistry from an abstract point of view were the Greek philosophers. The idea here is that they formulated ideas rather than the science itself. So they first laid the seeds that eventually did become chemistry as well as other sciences.
The big thing to notice about how they came up with their ideas is that they didn't have any formal experiments or experimental procedure. So these ideas or concepts that they came up with came from just observations, and they just thought things through, and they came up with the concepts of the four elements: earth, fire, air, and water, and how these four elements composed all the matter in the universe.
Yeah, the idea here is that these four components made up all of the different things that they saw in their lives, and the idea that these elements could be divided and cut in half basically forever. The two philosophers of record who really kind of helped pave the way for chemistry to emerge as a field are two fellows by the name of Democritus and then Aristotle, which you probably all have heard of.
Democritus came around first, and he came up with the idea that matter is not infinitely indivisible. Okay, so to remove the double negatives, it can be divided and divided all the time. And from this, he came up with the idea of the word atomos, which we later on reworked into the word atom. And also, a lot of these basic tenets that he came up with later worked themselves into more standardized concepts of atomic theory, which we'll go into in a little bit later. But the big things to cover would be the things that atoms have different sizes and shapes. They had different properties, and they can be grouped together in different ways to form different types of matter.
The one thing to point out here is that Democritus was kind of the person who was the rebel out of all this. That this idea of the atom was a very controversial idea and went against a lot of what the philosophers believed at the time. And so this idea that you couldn't cut things in half forever was a relatively new idea. And a lot of what he presents here is incorporated in the modern theory, but as you're going to learn in a minute, this wasn't just something that everybody accepted. That there were some problems when he did present this idea. Now, Aristotle believed in the four elements, and basically his idea was that these four elements could be combined together in different combinations and in different amounts to give rise to the different things that were observed in their everyday lives. And he was probably the most vocal critic of Democritus. His two main arguments that Democritus really could never answer is what holds these tiny little particles called atoms together, and the idea that the idea of empty space or nothingness didn't exist according to Aristotle and at that time. And to kind of give you some perspective, the idea of empty space wasn't really a favorably received idea until the early 20th century.
Because there was no way to prove otherwise at that point. So these guys were going off of just what they could see, and since they couldn't see emptiness, that was the conclusion that Aristotle came up with.
And so this is one of the problems without having experiments to kind of back up what you're talking about. Because without data and a way to prove what you're talking about, it's just basically conjecture. So if you put yourself back into this time, Aristotle's the big gun. He's very popular, and as a result, his theory kind of overwhelmed Democritus and his idea of the atom. And basically, this was accepted for a very long time.
And you hear it crop up every once in a while in other forms of culture or literature. We saw it in you see it in the cartoon series Avatar, Last Airbender, and a couple other things.
My favorite show.
And also, even in some older religions or belief systems like paganism and witchcraft with the four elements. That all came from the ancient Greeks and Aristotle's concept of what matter was made up of.
So let's fast forward a few thousand years and see what happened. So the next person of record to kind of contribute to the idea of the atom was a fellow by the name of John Dalton. John Dalton was a humble school teacher in England. Me being a humble school teacher, I could totally relate. And he basically revived the idea of the atom. However, this time, instead of just philosophizing based upon common sense, he went through and did a lot of research and did many experiments where he took copious notes of what he had done and what his results were.
So he made the first big steps in the atomic model, and when he posted his atomic theory, by this point he had proof from experimentation and research, and it was verifiable by the community at large, which is what launched his concept into the closest thing that we have for the modern atomic theory. And this was done over, 200 years ago. And this is after 1,000 to 2,000 years of regimented thought from Aristotle's chain of mind with four elements. So this was actually a big revolution.
And so let's look at his ideas. One of his ideas, and this is represented in many different forms over many different textbooks. So these aren't word for word postulates of his, but these are the general ideas of his theory.
And if you'll notice that they're very close to what Democritus came up with over 1,000 years ago as well.
So let's briefly go through point by point Dalton's theory. The first one is all matter is composed of extremely small particles called atoms.
And then that all atoms are given of a given element are the same, right, or identical.
Now the first one is basically true. The second one, as we're going to learn later on in this unit, that not all atoms of a given element are identical. There are going to be some minor differences that we'll talk more about. Atoms of a specific element are different from those of any other element.
Atoms cannot be created, divided into smaller particles, or destroyed. Now that one will also be adjusted later on. As you guys will probably know about something called nuclear power, there's your proof against that part of Dalton's atomic theory.
And different atoms combine in simple whole number ratios to form compounds. Now this is an important one because this will be a recurring theme throughout the beginning of this course. You've all heard of water being H2O, and the reason why it's H2O is it represents the ratio in which hydrogen and oxygen atoms combine together to form water, and we'll find that there's other similar types of ratios used for other compounds. But the idea of whole numbers is something to kind of keep in mind, where we're always going to have whole numbers and not decimals or fraction of atoms reacting.
And then lastly, there's chemical reactions, which are the rearrangement of the atoms from one type of compound into another, and we know these as chemical reactions.
Right, so all chemistry really is, if you think about it, is basically breaking bonds and forming new ones.
Like taking apart a Lego model and then reforming a new one, going from a car to a boat.
And that's basically what chemistry is, but of course much more complicated. To give you some reference in terms of the size of the atom, again, it's the smallest particle that retains the properties of an element. We could break down atoms into smaller parts, which we actually will in future sections of this unit, but it ceases to be unique to that element.
It stops acting like what it was as a whole piece.
And here are some little pieces of trivia for you. The number of atoms in a penny is a lot. I don't know that number. Go ahead.
Atoms can be visualized with a scanning tunneling microscope. And then also individual atoms can be moved to form shapes in simple machines called nanotech. And you'll be hearing more and more about that because it probably will be the next major wave of technology in the next 10 to 20 years.
And of course, once we define the atom and once Dalton's theory was accepted, many, many more questions about the atom emerged. And so the purpose of this unit is to kind of answer as many of these questions as possible. So until next time, I'm Mr. Sakaguchi.
And I'm Mr. Lin.